My name is Priyamvada Pundi. I've done my BTech, I've completed it. Right now, I'm pursuing masters in it. I have been certified with RHCE, Red Hat Certified Engineer, and also Red Hat Certified System Administrator. We'll talk about Hadoop today, and it is basically working on big data. And if we talk about big data, what is big data? By the name, you can understand the large amount of data. It's heaps and heaps of data. It could be structured and it could not be. It could be unstructured. Now, we'll understand what is structured and unstructured about Hadoop. Structured data, it means it is in a tabular form. It has relation between one table, second table. You can point out things, pick up things. But unstructured cannot be set in a particular set of table. For example, you can take images, videos, audios. You cannot put it into a table. Earlier, when we won't be able to use internet that easily, at that time, only documents were there, basically, and you just had your laptops, sorry, PCs, not laptops. And the computation and also the storage was done on your single system, which was PC. Now, as soon as internet prevailed, people started using it much and much. The unstructured data started accumulating. Now, to deal with that amount of data, it is not easy because in daily, if we talk about stats, daily, if you just Instagram, it reduces 1.435 trillion MBs of data per day. So you can understand how much amount of servers we need to store that data, and to pick out or to retrieve data from that heap is very difficult. So to solve that problem, which is a big data problem, we need some technology. It cannot be done using Google file system or NTFS or any, because that is just related to a simple system, or maybe cluster of 2 or 3. Cluster, by the term, is, what do you mean by clusters? There are groups of computers connected together, linked together, forms a cluster. It could be any 10, 15, 20,000. And when we are talking about big data, we talk about thousands of computers, servers linked together. It has, just don't know, it's infinite amount of data we have. So to deal with that, we had to come up with a technology which is Hadoop. So now, the basic thing about Hadoop is it deals with big data. How it deals with big data? Initially, when internet was not there, or when the data problem was not there, it was easy for your system to handle your data and to compute it. And by compute, whatever operations you want on your data can be done. But with the huge amount of data, you need a proper storing system so that whenever you want to retrieve your data, it is easy for you to get it and to do your operations on them and then get your desired result. The simple thing is this. And what is the need of Hadoop? For an instance, if you want something, if you type XYZ on Google, right? What will you get? Either they'll suggest you something, the Google will suggest you 10 to 8 pages or whatever, or it will say data not found, correct? When data is not found, it means the Google is not capable of retrieving the data. They can be two things. First, either the data is not there or it is not able to retrieve it. To retrieve your data, to give it to you, to operate on it. Now, when we talk about big data, Hadoop gives you two things to do. First, it will give you how to store your data, in which manner you will store your data, so it is easier for you to pick out the particular thing what you want in that trillion and trillions of data and to operate on it. And of course, you do not have time. You need your operations done in, I guess, in seconds. public has become, people have become impatient. You know, when everything is on your tips, you don't wait for anything. If it takes more than 30 seconds, you switch on to other things. So Hadoop solves that problem. Now we'll start with the introduction. What is Hadoop? How does it work? And what is the history behind it? How did it started? What was the need to start it? What are the features of Hadoop and the key technologies? If we talk about the key technologies, it basically is HDFS and MapReduce, which is how to store your data and how to get that data and function on over it, computation over it. Now, when we talk about other projects, it is Hadoop has an ecosystem. It is a technology, Apache technology. So it has, how do you enter the data into Hadoop? How do you retrieve it? How do the data from all over the world is put into the Hadoop database, you can say it. Correct. So how do you do that? With the help of those, ecosystem, with those apps, technologies, you use it. And then we'll finally conclude about Hadoop. This is just a basic knowledge about Hadoop. We'll learn it properly in detail, but this will give you an idea about Hadoop, that how does it work, where does it work, why do you need it, what is the necessity for it, and other things. So, introduction. By now, we know that what is Hadoop? It is basically a framework and it is open source. Now, when we talk about open source is that thing in which any person who knows that language, in which that particular technology or program is written, can enhance it, can read the information. That means you can read the code, you can enhance it, you can modify it. And when we talk about framework is basically, it is a structure, that in what structure your particular technology works. And in this case, in Hadoop's case, what we do is we store our data in HDFS, which is Hadoop distributed file system, and then retrieve that data if required, anyways, whatever the way you want, and then you perform computation over it. It means whatever operations you want to perform on that particular data which you want can be done, but it will be done with the help of MapReduce. Here we are talking about Hadoop 1, where we use HDFS and MapReduce. In Hadoop 2, there is something else. MapReduce was replaced by something else. So we'll talk about it later on, but it is called as YARN. Now, it is designed to handle big data, which allows for the parallel processing of large data sets. Now, this is very important. And why is it important? Because parallelly your data is being processed. This is very necessary when you have a large amount of data, huge. For example, if you want something, if you are going through serially through it, first this, then this, then this, and if it is at last, then what will happen? It will consume your time and you won't get the data in the desired time limit. So it is of no use because the data is too large. To retrieve that data would take hours and hours. So we need the parallel processing. We need not serially, parallelly, it should work on everything to get our desired data in seconds. So this is the problem, basic problem, which was solved by the Hadoop, that parallel processing of data happens. Now, Hadoop is open source, as I have told you. It is an Apache product. Apache is an open source platform, web platform. Hadoop is in Java language. It is written in Java language. It has Apache framework, which means it works on the Apache system. Also, it works on Linux. To install Hadoop, you will need the base OS as Linux. Now, it has HDFS for storage and MapReduce for computation. Many big technologies, as you can see on the screen, like Yahoo, IBM, Facebook, Google, eBay, Amazon, LinkedIn, big techie companies which have huge amount of data use this. The reason behind is you can retrieve data fast. the data is stored properly, the computation can be done properly. Now, if you have a doubt, what do you mean by computation? Computation can be anything. For example, you post something on Facebook, correct? Now you want to edit, like you have written something and you want to change that caption or anything. So what you will do, you will retrieve your data. I want this picture, yeah, I want this video, and then you'll open the edit part and then you'll write it down, something or the other. So what you're doing is you're writing, overwriting what you've done. This is for this, you need storage, HDFS. It will get your data back to you, and then you'll write it down. Now, writing is an operation. Read and write is an operation. This is the part of map reduce. So, map reduce will do what you want to do, and then it will be stored. This is how this whole thing works. Okay. Now we'll study why do we need it? What was the history behind it? Why was it necessary? So, co-founders of Hadoop was Doug Cutting and Mike Caffarelli. They both started it. Actually, they did not start to make Hadoop. They were just making a web search engine like Google, Safari, Mozilla, Chrome, etc. Okay, which was not in 2002. Now, if you are opening any web platform, web search engine, so you will need two things. First, storage and a little bit of computation you need, right? So for that, they started with GFS. GFS is Google File System. Google had GFS in 2003. So they thought we'll take that thing and we'll engineer for our nudge and then use that storage system for nudge because they were building their own platform. Later for computing also they used Google had MapReduce in 2004. So these both people used MapReduce from Google only. They reverse engineered it, which means they engineered MapReduce according to their own needs for their platform Nudge. It was around completed in 2005. Now something happened and they both left Nudge. They moved out of Nudge and made another independent platform which was called Lucene. What is Lucene? It has structured data. It has data in text format, document format. You can write anything. If you need, for example, it is like an essay. Okay? If you want something from it, you will just type it down and it would bring that particular part for you. So Lucy was a search engine, web search engine, but for text. You cannot find images, audios, videos, no, just documents. Later on, Doug joined Yahoo, and then he started with in 2008 with Yahoo only. He was working with Yahoo, but simultaneously he was working on Hadoop also. And finally, as you know, Apache is open source. Open source means people who know things about a particular language or a topic or a tech, they can come together and work over it. So they did that. Doug and the other people from Apache build up Hadoop. It is an active community. Active community means anyone can chip in for maybe programming or any other changes they want, enhancement, modifications, etc. At that time only, Hadoop was used by IBM, Twitter then, and now we call it X, Microsoft and Facebook. So these big companies were using Hadoop at that time. Now we'll shift on to key technologies. Before shifting on to key technologies, we should know that how is this helping us out? How is this Hadoop whole system is helping us out? For example, if you're working in any company, we'll say Amazon or Flipkart, take it. If it is a task given to you that pick out in Delhi how many people uses a certain kind of clothes or certain kind of shoes, how will you get it? You'll have to search the data, the big data created by the people of Delhi, and then you'll pick out things. You'll retrieve things that these are the most common things used by the public or people of Delhi. So we should share or we should have stock of this in Delhi. Getting it? This is how it works when we talk about retails, online or offline retails. If we will now, for example, we'll take the example of law enforcement. How Hadoop helps in law enforcement. Uh, Take for an instance that there is a burglary happened or some criminal activity happened. Okay, and some person identified that I know a little bit about that person. He might be that person. So how will you pick that person? You'll have to search from the big data of all the criminal records or the people. You have all the data of people around on Instagram, on LinkedIn, Google, Facebook. So you can pick people out. You can search them. You can point it out. This is the person. So you can do that by Hadoop because you have data stored properly, so you can retrieve data easily, and it would be beneficial for the law enforcement people to know the people that this is the culprit and to pick that person. So it helps also in the social part of our society. For now, we can take an example for real-time customers data also. Like if we take, for example, we'll take example of Misho. Right now, Diwali is going on. I mean, the festivities are going on. So real time is right now in this particular moment. What people want, what are they shopping about, what are their basic needs for right now. This is how it works. We'll search the whole HDFS for what? For the data about what people are wanting in this festive season, and that we'll show or we'll market in that sense that people will want that particular product from Amazon or from Flipkart or from my community. That is how Hadoop works practically in real life. So if you try to implement all these things, yeah, you can easily do that. Okay. Now we'll talk about key technologies, which is HDFS and MapReduce. HDFS is Hadoop Distributed File System. HDFS is basically based on GFS, and GFS is Google File System. And why GFS? As we know that when Doug was working on Nutch, he used GFS and MapReduce for that particular platform Nutch. So he used same technology for Hadoop also, and HDFS and MapReduce both. And it gives a distributed file system. Now, what do we mean by distributed file system? It simply is, for example, if you have 520 KB of data, correct? So it will distribute it like 128 KB here, 128 KB here, 128 KB here, 128 here, and then what we are left with is 8 KB. So this is how it distributes the file. It does not store the complete data at one place. This is how distribution of data works in HDFS. And when we talk about MapReduce, what is MapReduce? It is a parallel programming method or a module for efficient processing of large amount of data. We know that to retrieve data and to process over that data, that is when it is in large amount, it is very difficult for you to do that. There are thousands and thousands of servers, and how will you find out that particular data you need? So for that, you need parallel process of data from, if, for example, if the main node knows that the data might be in those 100 servers. So you will have to parallelly work over those 100 servers to process that data. Okay? That is why it is called as cluster. Cluster is basically nodes, thousands of nodes connected together to form a particular network. And that HDFS is stored on that network so that your data is particularly stored in a distributed and proper manner so that you can retrieve it easily. Okay. Now, it is stored, of course, on a hardware. Server is a hardware. You need a hardware to store your data, and it is fault tolerant. Now, this is a very important term because fault tolerance is if, for an instance, if there is no data, a server crashes or your data is gone at one place, you can find that data at the other place. This is fault tolerance basically is. Fault tolerance means your data cannot be missed. Whenever you search for the data, and if it is a valid data, it will appear to you. The HDFS system will give that data to you. This is how HDFS and MapReduce works. This is just an introduction. We'll learn about it further. Now, features about. I've told you it is fault tolerant, and fault tolerance basically is your data cannot be lost. If you have put something into the HDFS, somewhere or the other you will find that data. This is the guarantee taken by the Hadoop system. It is highly available. It means it is very easy to set up the whole architecture or the system of Hadoop. The programming in which this is done, Hadoopism, is easy. Java is an easy language comparative to others. It has flexible storage. It means flexible storage means, for example, you have a server. It has, for instance, we'll take a little bit less amount of it. For example, it can only store 50 GB. If you have another data, what will you do? Will you not store it? If the user needs to store another story or a picture, what will you do? So you'll need add-ons. You'll have to add on other servers and storage points, other data nodes, data centers. So what you will do is you can just connect that center to the recent one which is going on, and you can just shift your data. It is very easy to add on data centers to a particular Hadoop system, and also comparative to others, it is low cost. The amount which is required to store data is less. It is low cost in all the manners. In like time, it takes less amount of time. In monetary basis also, it is lesser than any other technology present. Okay. First, we'll talk about HDFS. Now, HDFS architecture basically it has two things. First is name node and second is data node. Now, how can we understand name node? Name node basically is the head of the organization. It is the head of the HDFS architecture. Anything you want to know, you'll have to first go to name node, and then it will tell you about where you want that data, what the client has to do. So if you want to if you want something, what you will do, you'll go to name node, and then that name node will direct you to the other data nodes. That here is your data, pick that data, and you're good to go. Now, there are several other things. For example, there are several data nodes, thousands of clusters of data nodes, correct? If you have put something, for example, I've told you like 520 MB of data you have put into HDFS, correct? Now, in this, one data node is of 128 KB. The block size is 128 KB. Only 128 KB of data can be stored in one data node. And then to the second data node, 128 KB. Then to the third data node, 128 KB. And this is how it goes on. The block size is 128 KB. Only 128 KB of data can be stored at one place. This is distribution of data. If you have 520 KB, you'll distribute that data into 128, and store it at several data nodes. So when you want that data, parallel processing can happen and you can retrieve your data in seconds. This is how it works. Okay. Now we'll understand what replication factor here is. Replication factor here is, for example, you have stored something and that particular data node fails. Now your data is lost, correct? If we do not replicate that data, that same data has to be replicated to other data nodes, so that if in any circumstance a single data node fails, you can retrieve your data from other places, other data nodes. Okay. The replication factor is always 3. 3 means first of all, wherever you have stored your data, and then 2 other nodes will have that particular data. This is how it works. 3 replications of a particular data has to be made. This is the rule. And why it is happening? Because of the fault tolerance. Fault tolerance, if, for example, a single particular data node fails, so your system will not show you that I cannot show you that data, right? It is the mistake of your system, of the whole Hadoop system. It cannot afford that. That is why it makes replications of your data so that your data is never lost. And for instance, if one server fails, it will make another replica of it at some other data node, so that your replication factor will always remain 3 at any cost. Now, there is another term which we call as rack awareness. Rack awareness means that a data node has racks, 128, 128, 128, 128 KB of racks. Only that block of data you can put into it. So if one data node has that particular data which you have input, you cannot make replica in that same particular rack. You have to choose another data node or another server for that. This is rack awareness. It means no two data can be in a single data node. Okay. So that you have properly 3 replicas. That is why we use rack awareness and replication factor. Data also you store your data locally. Why locally? For example, if you search something and it is in a server far away, what will happen is the amount of time to retrieve that data will increase. PD, that is propagation delay, will happen. Propagation delay means the data which will retrieve back to you will take time. It is in the form of signal, so it will take time to reach you. That is why mostly we try to keep data locally in your local center, so that whenever you will hit the button to search, it will just pop up the result in few seconds, not even few milliseconds. That is how it works. This is all about HDFS. Through the diagram, we learn a little bit about it also. Okay, so the whole MapReduce works on GFS. GFS is Google File System and HDFS is based on Google File System. So MapReduce, which is the computation part of Hadoop, works on HDFS so that the computation over the data can be done. GFS is not open source. Google File System is not open source, but this HDFS is open source because Hadoop is a part of Apache group, so it automatically makes it open source. Doug and others, people used GFS as the base for HDFS. They reverse engineered GFS, Google File System, to make it HDFS. HDFS, why HDFS now? Because it provides better data throughput. Throughput means you can get your data easily, retrieve your data easily in lesser amount of time, and also monetarily basis you will get it easily. In addition, it has high fault tolerance and native support of large data sets. Native support means I told you locally we store data so that it is easier for the native people to get the, for example, you live in Delhi, right? What does Delhi people usually search about? They'll get that data into the local server, so that whenever any person from that particular geographical area hit the search button, they can get their data easily in seconds. Also, it is inexpensive, immutable. Immutable means it will not mutate naturally. If you want some changes into the HDFS, you can do it, but naturally it won't be possible. It is reliable because it has fault tolerance. It is scalable. You can scale your data. Scale means you can increase the amount of servers at infinite. You can increase HDFS, which means the storage system can be increased infinitely. Whatever amount of data you want to input into it, you can do that. And also it processes it also inserts. It means it saves the data to your system, stores the data to your system, and also it parallelly it processes your data. It retrieves also. It works parallelly everywhere. This is the whole thing about HDFS. How file system of Hadoop works, how it distributes data properly in blocks, how it is very essential for it to be distributed so that you can easily, parallelly and easily retrieve your data and then work over it. Now we'll read about MapReduce. Now what is MapReduce? It is shorter form of mapper and reducer. Map reduces, short for mapper and reducer. Now, what is mapper and reducer? First of all, mapper and reducer works for processing. Map reduce is for processing, not for storage part. It processes your data. It has two tasks. It maps your data and then reduce your data. As when we talked about HDFS, it had a head node, which is name node, and the lowers were data nodes. So head node, which was name node, works, manages everything. In MapReduce, there are two things. First is job tracker. Second is task tracker. Now here, job tracker is at the upper level. It is the head, and then task tracker will work accordingly. It is the below part. It is the employee. You can say that. Job tracker is the head and the others are employed. They actually work, and the upper one just manages the thing. Now, tasks are mapper and reducer. And daemons. What do you mean by the word daemons? Daemons are actually job tracker and task tracker. Daemons are processes, background processes which work when you hit on to job tracker. What happens? The mapper works. Job tracker is it runs on background. You don't know that it is working, but it is a daemon. Okay. Now, what is the work of job tracker? It schedules your data, it manages your data, it provides resources to the task tracker so that whatever the amount of operations you are, for example, if you need to read or write, if you need to print, or if you need to make any changes into it, into audio, or you need a video, anything. So that thing is done by job tracker. Whatever resources are required, whatever management is done, whatever the scheduling of the things are done, and monitoring over the task trackers are done by job tracker. The processing unit of Hadoop is MapReduce. Now, how does it work? First of all, you input a data set. Here it is written that you input a data set. Record have different kinds of maybe audio, maybe video, or text, or documents, or images are written on it. The record is that. Now what happens is the data will be split into a single entity. For example, if I've written my name is Priyanka. So what will happen is the split part will what splitter will do, it will split my part. Like I'm studying Hadoop full stop. I'm quite interested. It is a quite interesting topic, full stop. It has HDFS and MapReduce full stop. So these full stops will be splitted by the splitter. One will be that I'm studying about Hadoop, and it is very interesting. Second and third will be it is HDFS and MapReduce. Now what will happen is I am. So I will be I is one single entity. AM is second single entity. HDFS is third single entity, and so on. Now mapper, what does it do? It gives key. Key is like I is the key, and value means how many times I has occurred in this particular sentence. So one time I am studying Hadoop. I has occurred one single time. The value will be one, and the key is I. Am also one. Hadoop is also one. Now, if you have used Hadoop 10 times, so what will happen is the value will be increased. 2, 3, 4, 5, 6, 7. This will happen. Sorry. What will reducer do now? Splitting is done. Mapping is done. In mapping, after mapping that I has occurred 2 times, Hadoop has occurred 3 times. This is mapping. It will tell you what amount of data has occurred, how many times in your particular record. Correct. This is how it stores. Okay. And then shuffling and reordering is done. Shuffling, for example, A to Z, it shuffles, right? Reordering of the data is done. Now the reducer part comes. What reducer does is and it will tell you that it has occurred 3 times or 4 times, and then finally the final data set, the final result will be stored in a way so that whenever you want to do any operation on it, will be easier for you to retrieve it and do. Okay, now we'll talk about how does it work. This is the whole processing of it. This is the way the map reducer. I know it is a little too much. You will need time to grasp it. It will happen, don't worry. Now, map reduce is basically processing system, correct? So whenever you want to process things, you want if you want to make any changes, if that that thing will go around and down to yeah, it is processing, you will get irritated. Anybody can. So to reduce that thing, to reduce that time, this mapper and reducers are working. And behind these mapper and reducers, the job tracker and task tracker are there. Now what happens is, for example, when your data is stored in HDFS, data will not go to map reducer and will work because it will again increase your propagation delay. Understanding it? What will happen is Hadoop will send its job tracker and task tracker. It has the job tracker has task tracker to do work. Task tracker will send to the particular place. Data node 1. It has the data, your data which you have retrieved is on data node 1. So task tracker will go to that data node. Whatever processing you want, it will go and do there. The data won't come up to task tracker to do your work. No, it will increase your time, and which we do not want. We need fast response time, very minimal response time. So task tracker will go to that particular data node. It will work whatever you need to do, and then will come back up and show that particular result, the final data which you want on your screens. This is how the whole HDFS and map reduce works. On the upper level, it is the upper level. It has the whole the depth of it. We learn about it. How the particular programming, what do you write, how do you do it, how do you store, what are the commands to write it, how do you retrieve your data, how do you work over it. This will all happen in a while. Okay, so again, this map reduce model was designed by Google, as we have discussed earlier. It sorts, I have told you that after mapping, it sorts your data, reshuffles your data, schedules your data. Initially when this technology was started, indexing it was basically for indexing. Like indexing is when you retrieve your data. When you want to retrieve your data, index helps. So MapReduce was just for indexing and searching. So it was used by IBM, Yahoo, and Amazon. Also others also, but these were the big techies who were using it. A framework that helps programs to do the parallel computation on data. Now, you already know that data is in blocks stored in HDFS. So on those blocks, the work, the job tracker, there are job trackers, so they will work parallelly over all the data you have, and then will give you result. For example, if I have told you about the 520 KB of data, if that 520 MB of data, if you're working over it, serially, if you're working on it, for example, it will take 1 minute. But if you're working on it parallelly, it can happen within 10 seconds. Because parallelly, you just have to work over 128 KB of data. It is very easy for you to do it. Correct. So that is why parallel computation is necessary also. It decreases your time. The map task takes input data and converts it into data set. What mapper does is it can take your data and make it into a particular data set. I've told you that key and value thing. The key value pairs, it makes into key value pairs, and the output of that map task is then reduced. Reduced means if you have I 10 times in your particular data set, so it will just write I, comma, and value is 10 because 10 times I has occurred, and that it will index it to your whole data set. So that you will get the aggregate output, and so it will also reduce the amount of size to store your data. If you have data in your MBs, so maybe it reduces your size to KBs. It is a very, very useful technology. Underlying system which takes care of the partitioning of the input. Partitioning means when mapper and reducer go to partitioning of the input data, the scheduling programs, execution across several machines, handling machine failures, and managing requires inter-machine communication. It means the part mapper and reducer part when you partitioning data, which when you're sorting the data, scheduling the programs into the machines. If any machine fails to store the data, what will happen? How it is going to manage that thing? This whole thing is look after by job tracker, which is the part of MapReduce. And for this, you need inter-machine communication. For example, you have 5 data nodes, so every machine should be communicating with each other so that they know that they're at the same pace. They have stored their data, they're working on it parallelly, and they'll put out the result in front of you in milliseconds. That is that they need intercommunication between each other so that no fault can occur. This is the basic thing about MapReduce. Okay. Now, projects on Hadoop. As you know, Hadoop is an Apache thing. It is open source. Now, to input data into Hadoop or to retrieve data, you cannot do it just like drag and drop. No, you will need some technology, some app, something to work over it. So this is the ecosystem of Hadoop. Not the whole ecosystem. It has other technologies like Mahout and HBase, those other things also. But first, we'll start with Zookeeper. What Zookeeper does is, look at the picture. It is basically, it is looking like a person who keeps a watch. It means it manages everything. Now you can say that it is also done by HDFS and MapReduce. So why do you need another tech for Hadoop? Ki Zookeeper will take care of everything. See, when we talk about HDFS and MapReduce, it works on that particular data center, on that particular server. But intercommunication between all the data sets and how to manage it is done by a Zookeeper. When the data is in huge quantity, it is a big data. So when we are dealing with the big data, and that to intercommunication between, inter means this a data set is here, this is a data node, another data node, another data node, another data node. So the communication between all these, there are thousands and millions of data nodes. No? The communication between all of it is not looked after by HDFS and MapReduce. It is done by Zookeeper. HDFS and MapReduce can look after 10 or maybe 20, but when you're talking about 1,000 and more than that, then Zookeeper will come into play. Okay. Now we'll talk about PIG. PIG is high level data flow language and execution framework for parallel computation. It is basically scripting. Script is in what form you write the language. Then we write in Java, right? So if in Java the code is of 100 or 200 lines, it consumes your space. If you want to retrieve some data and if you're writing it, it is of 100 and 200, it doesn't make sense. So to shorten that query or to shorten that thing, you use PIG. It is a framework for parallel computation. Whatever you want, you can just use this language. PIG is a language, so you can use it. It is very easy. It makes your code very easy to work on Hadoop, HDFS, and MapReduce both. Now we'll talk about data. Hive, a data warehouse infrastructure that provides data summarization and ad hoc query. It means it is a infrastructure which gives you summarization. Summarization means whatever you want in a brief format provides. And how it basically works, it is just like SQL query. Structured, it is basically for structured query languages. Hive works for structured data. When you have a data in structured form, that means in tabular forms, when the relations are particularly formed between it, there are no images or just a single type of data, that is documents, or maybe just images, a single type of data. At that particular time, you use Hive, it is SQL, query language, so that you can retrieve your data easily, fast. But only for structured, not for unstructured. For unstructured, you have another tool. Now, Scoop. Scoop is a tool which transfers data from the outside world to the Hadoop system. servers are inputted, are given many data. How to take that data into the Hadoop HDFS system is done by Scoop. It is ingestion of data into the system of HDFS, Hadoop system, ecosystem. For structured data, we use Scoop. And for unstructured, we use another tool which is called as Flume. Flume is also part of Hadoop ecosystem. So for structured, if the data is structured, you will use the tool Scoop to enter that into HDFS. And if the data is unstructured, you'll use Flume for that. Now, we'll talk about what did we learn about Hadoop. We'll just rewind it a little bit. Hadoop is working. Why we need it? For the big data, because the data in nowadays is unstructured. Unstructured means it is not in, we just don't have text or documents. We have images, we have audios, we have videos, graphics, GIFs, many things. So to handle that data, and that too, we are producing trillions and trillions of data in a day. To handle that data, it is very difficult for the traditional system, the NTFS system, GFS system. It is not easy for that, for them to do it. So that is why we introduced a technology called Hadoop. Why did we use it? So that the big data can be managed properly, and also we can understand that it is easy for us to retrieve and to do computation. It is very easy to install, and it works on Linux workstations. It does not work on Mac or on Google or on Microsoft. Microsoft is working on it to incorporate Hadoop into it, but it is right now working on Linux. It takes care of hard problems. Hard problems are failover. Failover means fault tolerance, basically. Your system, the data which you have inputted into the system cannot go anywhere. It should be there whenever required. Good web-based monitoring tools. It has monitoring tools like we have read before, Scoop, Hive, Flume, Pig. These are the monitoring. Zookeeper is a monitoring tool. So Hadoop has that. It is scalable. You can add many things to it. It is also flexible. It does not require you to send or store a particular set of data. You can just input images, or in only 20 words you can write it down, or just one page. It does not have any boundaries. It is flexible. Whatever you want to write it, what you want to input into it, you can do it. Parallel processing is the most important thing of Hadoop, and it is resilient to failure. It means it will not fail. This is the most required part of Hadoop. If it fails, it doesn't work. Okay, so this is how it works. A little bit about HDFS. We have, so I told you about that there are name nodes and data nodes. A little recap over it. Name node is the head. The data node are the workers which does the job. Now, how, if name node does not do anything, why do we require it? What is the need of name node? Because it is not doing anything. Data nodes are doing things. So the work of name node is to manage data nodes. Okay. There is a term called FS image in name node. What FS image in name node does, it particularly, it is a, you can understand, it is screenshot of the state of your name node right now. That your file system, the whole HDFS file system, it is a screenshot of that on the name node, so that the name node knows what is going on in my file system. Are there any changes made or not? Now, edit log is another thing in name node which it takes care of. Is if any changes or modifications are done, it will update that. This is what in my file system has been changed. So edit log has all the details. There is also another term called secondary name node. What is the use of secondary name node? The term FS image, which we have learned, FS image is the screenshot of your whole system, file system. That is taken care by secondary name node. Because name node is busy managing and providing resources, managing all the data nodes. So what secondary name node works over it? It makes the FS image of your data, HDFS, your file system, and saves it onto name node. One more thing name node does is it takes heartbeat of every data node connected to it. Heartbeat means in every 3 seconds, every data node connected to a particular name node sends a signal that I'm alive, that I'm working, I did not fail. This is what is done by name node. It manages many things, and that is sometimes, and also if sometimes name node fail, then the secondary name node works over. And as soon as the main name node starts working again, it gives that particular control to main name node. But if even if main name node fails, the secondary will work. So it is completely failure proof system. It cannot happen that this Hadoop system will fail. At any cost, either for storage or for computing, this system will never fail. It is made fail proof by Doug and everyone. So this was it about our system. Thank you so much for your patience and time. I hope you have learned a little bit about Hadoop. And then this is the base of it. The whole knowledge I've given you about how does it work will go into the